We've worked a lot with leading one coefficients in each row of a matrix. These help us identify the number and types of solutions that a system has. And we have a name for these leading one coefficients. Leading one is the first one that we see. So the first or leading one coefficient in each row after matrix reduction has been performed is called a row pivot or non-zero pivot. The reason it's called a pivot is because essentially that value has been used to cancel out all of the non-zero values above or below it. So pivot, it's sort of like in basketball when you're standing on both feet and you can't dribble anymore, and now you have to keep one foot planted and pivot around with the other foot without removing the pivot foot from the ground. If the row has all zero coefficients, not necessarily a zero constant, right? So we're talking about coefficients here. We have a constant column, and that constant column can be whatever it wants to be. If the row has all zero coefficients, not necessarily a zero constant, then it has no row pivot. Okay, so as long, and we'll make this statement here, as long as there exists at least one solution, the variable or column that each row pivot represents is not a free variable. Okay, so this allows us to identify whether a system has free variables, and if so, how many. So let's look at this first example. Here we have the equations 1x plus 4y equals 2 and 6x plus 8y equals 2. And after we've done some Gaussian elimination, we get the reduced row echelon form, which appears as this. Now let's identify the row pivots. So in the first row, we have a leading one in the x column. Okay, so on that basis, in our statement here, this variable is not a free variable. Okay, meaning it is fully determined. Okay, we'll come back to that in a second. Let's go to the second row. Is there a leading one? Is there a row pivot? Well, yes, there is, and that is in the y column. Again, we're excluding the constants from the idea of a row pivot. A row pivot has to be a coefficient. And so when we read this reduced system off, we see that this says 1x plus 0y equals negative 1/2. And 0x plus 1y equals 5/8. Well, given that there are only two variables, and based upon our statement, neither one of them is free, that right there tells us right away, without actually even writing the equations out, we know that x and y are going to take on only one value. And in fact, we could see that x is going to be negative 1/2, and that y is going to be 5/8. Okay, so we had two variables, we had two row pivots, and therefore we have a single solution. In our next example here, something is a little bit different, and this system, 1x plus 4y equals 2, and 2x plus 8y equals 2. Now, if we actually look at the system, we notice that the coefficients of x and y from the first row to the second row are just doubled. However, 1x plus 4y equals 2, and the statement 2x plus 8y equals 2, which is really 1x plus 4y equals 1, leads to something a little bit different. In this case, yes, if we look at the first row, we have a leading 1 in the column of x. But if we look at the second row, there is no leading 1, because we're only looking at coefficients. But this row actually leads to the statement 0x plus 0y equals 1. Or 0 equals 1, which is a false statement. So this system actually has no solution. And this is in our exception in our description above, where as long as the system has at least one solution, then we can go and talk about these pivot columns. But if it has no solution, then whether or not a row has a pivot is irrelevant. At the end of the day, there's no solution to that. Let's look at a slight variation of this. Let's say we change that constant, same system, except we have 2x plus 8y equals 4. And 2x plus 8y equals 4 is the same thing as 1x plus 4y equals 2 if you divide both sides by 2. So these are actually the same line, and I've designed it that way intentionally. Now as we look at this system, we don't have the statement 0 equals 1 like we did above, but we notice that in our first row we have a row pivot of 1 in the x column, so x is not free. When we look in the second row, well, both of the coefficients are 0. We've run out of rows. Y does not have a leading 1 in any of the rows. Therefore, y is a free variable. Okay, why is that? Well, because the second statement, the second equation just says 0x plus 0y equals 0, which effectively just means 0 equals 0. That's a true statement, not a helpful one. The first equation says x plus 4y equals 2. Well, that doesn't tell me what x equals, but it does tell me that as long as I know what y is, I can determine x. As long as I know what y is, I can determine x. Okay, well, I don't want to pick a number for y. I don't want to specify it anyway. So what I'm going to do is I'm going to say let y be some number on the y number line. We're going to refer to it as c. So if we let y equals c, and notice that because the non-zero pivot or the row pivot is in the x column, this is easy to solve for x. All I have to do is subtract away 4y, and I get x is equal to 2 minus 4y. And we're just saying we're picking a value for y. And so we see that whatever we pick for y, x has to equal 2 minus 4 times that. And so our solution is our solution set. It's a set of solutions, because there's infinitely many of them, is c and 2 minus 4c. So whatever I plug in for y, I just have to make sure that x is 2 minus 4 times that. And you can pick values all day long. For example, if c is 0, and that means y would be 0. If we pick c equals 0, then x and y are going to be 2 and 0. So we can just check that 1 times 2 is 2, plus 4 times 0 is still 2, and so we get 2 equals 2. 2 times x, 2 times 2 is 4, plus 8 times 0 is still 4, and 4 equals 4 is a true statement. So this is just one possible value that we could pick for. Now, all we had to do to identify that y was a free variable now is to look at all the row pivots and identify any columns that do not have a row pivot in one of the corresponding rows. Now, here's a really trivial type of case. This case is not very interesting because ultimately the equations that we have here are 0x plus 0y equals 0 and 0x plus 0y equals 0. Well, if I asked you, what values could I plug in for x and y to make these two equations true? I hope we would say that you can plug in anything that you want, right? Anything can go in for x, because no matter what x is, 0 times it will be 0. Similarly, 0 times anything will be 0, and when you add two zeros together, you're still going to get 0. But let's try to see how this idea of pivots work. So what do? Well, I'm going to look in the first row. I don't have any row pivots. I look in the second row. I, again, don't have any row pivots, and so what that means is that x is free and y is free, which makes sense because we just said we can plug in anything that we want. This is just a nice way to be able to identify it. So what do? Well, we say let x be some number, some real number, and let y equal some other real number. So c and d are just any real numbers. So our solution is like this: xy equals cd. Okay, so c you can pick, d you can pick. You can set x to be 100 and y to be 1,000. So c is 100, d is 1,000, and guess what? It works in this equation because we're multiplying by 0. Okay, now we can have systems with more variables. Let's say we have, and we can call these variables x1, x2, and x3, or we call them x, y, z. There's not a way we have to name them. I'm just going to call them x1, x2, and x3 here, because that's a lot of times how we tend to write solutions, because we run out of alphabet letters sooner than we do numerical subscripts. Okay, so this system reduces to this one here, x1, x2, x3, and our constants. And again, we're going to proceed. In the first row, where is our leading one, our row pivot? Well, it's in the x1 column, so that means x1 is not going to be free. Row 2, we look for our leading one, and it's in the x2 column. x2 is not going to be free. We look in row 3, there are no leading ones in the coefficients. And so because x3 doesn't have a row pivot ever in this matrix, that means x3 is going to be free. Once again, we can see why if we write these equations out. First equation is 1x1 plus 0x2 plus 1x3 equals negative 2. The second row says 0x1 plus 1x2 plus 0x3 equals 4. And all right, yeah, we can see that x2 isn't free. x2 has to be 4. But notice that in the first equation, x1, its value will be determined based upon what you plug in here for x3. And so we could plug in any number that we want as long as x1 plus that number equals negative 2. So once again, for free variables, we'll say let x3, our free variable, be some constant. Okay, now let's write our general solution. x1, x2, x3. We just said x3 is any number we want to pick. x2 has to be 4. And then what does x1 have to be? Well, x1 plus x3 equals negative 2. So subtracting away x3, we have x1 equals negative 2 minus x3. And x3 is this constant that we choose. And so once again, we see here that as long as I specify what c is, that gives me what x1 is as well. And so we have infinitely many solutions. We only have one free variable. So I got one more example here. Here I have 4 variables. So let's say x1, x2, x3, and x4, and then my constants. And that reduces to this system over here. So I hope we're seeing at this point why looking for the row pivots is valuable. It's just a faster way to identify which variables are free. When we write out the equation, that's a little bit more apparent, but going through this process at least helps us figure out how many assignments we're going to have to create, like x3 equals c, or back up in the previous example, x equals c, y equals d. Okay, so row 1 has a row pivot in the x1 column. Row 2 has a row pivot in the x2 column. And row 3 has a pivot in the x4 column. Run out of rows. There can only be 3 row pivots. And there are 4 variables, which means, hey, you know what? x3 is a free variable. Let's again write out these equations. First one says 1x1 plus 0x2 plus 1x3 plus 0x4 equals 6. And right now, I hope you're seeing that this value, x3, is not specified, and we get to pick what we want to plug in for it. Second equation says 0x1 plus 1x2 plus 0x3 plus 0x4 equals negative 10. All right, well, yeah, x2 isn't free. x2 has to be negative 10. And then the last row says 0x1 plus 0x2 plus 0x3 plus 1x4 equals 3. And we can see that x4 can't be anything we want it to be. It has to be 3. The only value that we have no stipulation on is x, is the value of the variable x3. And so what do? Well, we say let x3 be some constant. And once again, I just want to emphasize that we're not just replacing one letter with another variable. We're saying x3 is a whole continuum from negative infinity to positive infinity. Let's just pick a value somewhere on that number line, and let's call that number c. So x3 equals c is just a specific number on that number line. Okay, let x3 equal c. Okay, so I think I'm ready to write my solution set. Let's write down the ones that are whose numerical values we know. x4 has to be 3. x2 has to be negative 10. And now we said x3 can be any number we want it to be. But x1 plus that value have to equal 6. So x1 has to be the difference between 6 and x3. In other words, subtract away x3, and that means x1 has to be 6 minus whatever value we give x3. And so there is our solution. Now in some cases, with 4 variables, you could just have, as just a quick example, let's say I've reduced something and I get 1, 2, 4, 6, and then a constant of 5, and then I just get zeros on all the rows below it, depending on how many rows we have. Well, in this case, I go through the same process. x1 would not be a free variable, but row 2 has no non-zero pivots. x3 has no non-zero pivots. And so that means x2, x3, and x4 are all free. They would all be free in this example. Well, once again, the reason they would be free is because this first equation just says x1 plus 2x2 plus 4x3 plus 6x4 has to equal 5. I don't have any information about what x2 through x4 have to be, therefore I can plug in any numbers I want for them. But then I have these 3 degrees of freedom, but then x1 will have to be 5 minus 2x2 minus 4x3 minus 6x4. So this process works as long as you don't have a row that says 0 equals 1, like we did in our second example.